Space beckons us. It whispers of distant stars and unknown worlds. Looking up at the night tree of light. Each point of light is a sun, often with its own planets. Our sun is just one star in the Milky Way galaxy. The Milky Way itself is just one of billions of galaxies in the observable universe. Staggering. Our closest celestial neighbor, the Moon, is about 240,000 miles away. Mars, a planet we dream of reaching, is millions of miles away at its closest. Reaching the edge of our solar system would take... And the nearest star system, Alpha Centauri, is trillions of miles beyond that. The vastness of space is almost impossible to grasp. Yet, we are drawn to explore it. We long of the universe. We yearn to know if we are alone. To embark on these journeys, we need vessels capable of traversing the cosmos. We need spacecraft that can carry us to the edge of the unknown. We are still exploration. Our current spacecraft are like primitive boats compared to the starships of science fiction. But with each mission, we learn more. We push the boundaries of technology and human ingenuity. The universe may seem impossible, but remember, every great journey begins with a single step. Imagine a spacecraft capable of traveling to the edge of the universe. It would be unlike any craft we've ever built. This vessel wouldn't just be a machine, it would be an extension of our minds. A mind-based spacecraft would utilize advanced technology to interface directly with the thoughts and intentions of its crew. This would allow for intuitive control and navigation. It would also minimize the need for complex physical controls. But even a mind-controlled spacecraft would need powerful propulsion systems. Traditional chemical rockets are useful for escaping Earth's gravity. However, for interstellar travel, we need something more efficient. Perhaps fusion engines, which harness the power of the stars themselves. Or maybe even exotic technologies like warp drives bending the fabric of space-time. Of course, a journey to the universe's edge would take time. A long time. Our spacecraft would need to be self-sufficient. It would need to recycle air and water and perhaps even grow food. It would need to be shielded against the dangers of deep space, like radiation and micrometeoroids. Communication would also be a challenge. The farther we travel from Earth, the longer it takes for signals to reach us. Our spacecraft would need advanced communication systems. These systems would allow us to stay in contact with Earth. They would also allow us to transmit our discoveries back home. Before we can even think about reaching for the stars, we have to escape the gravitational pull of our own planet. Earth's gravity is a powerful force. It's what keeps our feet firmly planted on the ground. It's also what makes launching a spacecraft into space such a challenge. To break free from Earth's gravitational grip, we need rockets, lots of power. These rockets burn massive amounts of fuel, producing tremendous thrust. This thrust propels the spacecraft upwards, fighting against the pull of gravity. Think of it like jumping. The harder you jump, the higher you go. Rockets are like that, but on a much grander scale. The first few minutes of launch are critical. The spacecraft is at its heaviest, laden with fuel. It must reach a certain speed, called escape velocity, to break free from Earth's pull. As the rocket climbs higher and higher, it sheds stages, discarding empty fuel tanks to become lighter and more efficient. Finally, when the last stage burns out, the spacecraft is in space. It's free from Earth's gravity and can begin its journey into the cosmos. But reaching orbit is only the first step. To travel to other planets, or even further, to other stars, we need even more powerful rockets and innovative propulsion systems. A journey to the universe's edge would be as much a mental and physical challenge as it is a technological one. The human body, designed for life on Earth, is ill-suited for the rigors of deep space. We would face numerous challenges. These challenges include radiation exposure, muscle and bone loss in microgravity, and the psychological effects of isolation and confinement. Imagine spending years, perhaps decades, inside a spacecraft. You would be far from home, with limited contact with loved ones. The vastness of space surrounding you could be both awe-inspiring and terrifying. In such an environment, the human mind could be its own worst enemy. But humans are remarkably adaptable. We have an innate drive to explore, to push beyond our limits. On a journey to the universe's edge, our brains might undergo remarkable changes. We might develop new ways of perceiving and interacting with our environment. We might even unlock hidden potential within ourselves. And then, there's the overview effect. Astronauts who have seen Earth from space often describe a profound shift in perspective. They see our planet not as a collection of countries and continents, but as a single, interconnected sphere. A fragile oasis of life in the vastness of space. This experience can have a life-changing impact, fostering a sense of global citizenship and a deep appreciation for the fragility of our planet.